Hello, everyone. It's Friday, which means it's science. So, were we going to try to do that together?
Yes. One of these days we'll get it.
Whatever. So, it's Dr. Lex
And Dr. Demos.
and our very trendy cocktail this week. Cheers.
Cheers.
So, we're trying the Negroni Sblagiato, which is essentially a Negroni, except not with gin, with Prosecco.
Oh,
It's a little less boozy. What do you think?
refreshing. I love the orange.
Yeah, it's a nice one. Maybe someday we'll move away from red cocktails.
No,
Probably not until we finish that bottle of vermouth, though.
that's going to take a while.
So, I'm going to go first this time because
Yes.
I'm very excited about this article.
Yes, I know you are.
So, I study infectious diseases. I love all things creepy and crawly and buggy, and I mean, I don't like having them. They're
But
fascinating.
not spiders.
You're not actual bugs.
No.
Well, no bugs, but spiders are not insects.
Mm.
They're arachnids. But you're correct, I do not like spiders. But it's really interesting. So, a team of researchers discovered that there was actually genetic natural selection from the bubonic plague, the Black Death in Europe.
Of humans.
Of humans, yeah. So, well, obviously the bacteria changes genes or mutates genes fairly frequently. So, the Black Death is the particular. There are several different waves of plague. This particular one that we're talking about is called the Black Death, and it struck Europe in 1348, and it killed a lot of people all throughout Europe. And it's said to be the strongest pulse of natural selection yet measured in humans.
Oh my goodness.
Mm-hmm. So, the plague is caused by bacteria, Yersinia pestis, which is found in fleas. And this is why you do not adopt wild prairie dogs, because they carry plague. No wild prairie dogs. They look cute. Don't bring them home.
But the fleas on the wild prairie dogs carry plague?
Mm-hmm.
My goodness.
Yeah,
but
it's a thing.
if you've been naturally selected, then it's okay.
Not necessarily, because you don't know that.
Oh,
And as we'll get to, it's not like a perfect protection.
okay.
Yeah. So, people have suspected this has happened for a while, but there was really no way to prove it. So, Dr. Barriero and Dr. Poinar took DNA from bones of skeletons of individuals that lived before and after this plague from London. And they compared the DNA, and they saw 35 mutations that were changed in people after the plague.
Amazing.
That's still not proof of natural selection because genes can change in humans over time. It's called genetic drift.
Okay.
So it can kind of just happen on its own without any evolutionary pressure. So this is a really interesting part of what they did. So to prove that it was natural selection, they took what scientists call junk DNA. There's large stretches of DNA that don't really do much, kind of filler.
Junk DNA.
Junk. Filler DNA.
One day we'll figure it out.
There probably is a use for it, we just don't know yet. But, so what they did is they looked at mutations in that region of the DNA as sort of a standard, right? So if there's genetic drift, then it'll happen in those regions. Because those regions aren't used for anything, there's no evolutionary pressure that would cause that mutation.
So the junk DNA shouldn't change.
No, it'll change, but it'll change by genetic drift and not by selection pressure.
Oh, cool. Okay.
And so anything that happened faster, any mutation that showed up and stayed faster than the mutations in the junk DNA would be most likely caused by a selection pressure.
So in a traditional laboratory experiment where we have like a control and a test, the control is the junk DNA.
Correct.
How cool is that?
Yeah, it's really cool. And so they found, they found there's hundreds of genes that changed pre and post the plague. There are 35 that they think are from natural selection because they happen faster than the genetic drift in the junk DNA. They did the same experiment in Danish people, and they found 4 genes that were the same, that were changed and the same between the London population and the Danish population. And when you look at those genes, one of which is AREP2, and they determined that if you had a double, 2 versions of the AREP2 gene, then you were 40% less likely to, no, you're 40% more likely to survive the plague.
Just because of an additional
One
gene.
yeah. And this gene is responsible for, so when a pathogen enters your body, some of the first cells that see it are often antigen-presenting cells.
Okay.
And the job of these cells is to take little bits of that bacteria or virus and stick it on their surfaces, and it's an alert system for your body. It says, look what I found, it's not good, everybody come now. So ARAP2 makes a protein that does the snipping of the foreign entity in your body.
So if you have more SNPs, you get more alarms,
Theoretically.
which means faster immune response.
Right. The downside, because there's always downside, the downside is that people who with these two protective ARAP genes are more likely to have autoimmune diseases such as Crohn's disease. Because they think that the ARAP, because it's part of what's your body, what's called your innate immune response, which is not specific, so it can't tell what is you and what is not you.
So it can attack your own cells.
Right, yeah. So I just thought it was, and they're obviously going to be doing more work looking at the other genes, but I thought this was really fascinating that a protective mechanism that we as humans developed against the plague is actually causing a bit of problems much later on.
So if we develop medicines to fight autoimmune diseases that are based on shutting down the ARAP2 overabundance, would that make us then potentially more prone to the bubonic plague?
But it's already happening. Anything that we do for autoimmune diseases currently is a broad spectrum anti-immune
Just
treatment.
tamps down that immune
Yeah,
system.
so people who have Crohn's disease or other chronic autoimmune diseases end up being immunocompromised and more prone to getting sick. Yeah,
And that's by the medications that they're taking to manage Crohn's disease, for example.
Yeah. Like one is a TNF alpha inhibitor, and TNF alpha just is one of those molecules that, like, once your immune system gets started, it's just kind of everywhere.
Okay.
Yeah.
That's fascinating.
I thought it was super cool.
Yeah, it's a neat article.
Yeah, because my research in my PhD was dealing with this idea of how infectious organisms change our immune responses, especially over time, because I studied worms, and they end up in your body for about a decade, and they absolutely mess with your immune responses while they're there.
But there was an interesting article I think on stuff you should know about hookworm and about why you dig a 6-foot hole instead of a 4-foot hole for a place you go potty in the woods. But that hookworm, if it goes into your intestines, does have an immune suppressing effect.
Yeah, well, but it makes sense. It doesn't want to be attacked.
Exactly. So then, here's the question then. So in other words, humans were, by being naturally selected through bubonic plague, you get more allergies. You've got more involved immune systems.
No. The allergy connection is not.
That's not an autoimmune thing.
No, because you're reacting to an allergen. You're not reacting to yourself.
Oh, but not everyone has allergies.
I know. I'm just saying.
Okay, I always thought it was autoimmune.
No, autoimmune means you're attacking yourself.
Okay.
So it's things like Crohn's disease and arthritis, rheumatoid arthritis. I think psoriasis might be. Yeah.
But then, if it's a foreign thing, is it still the same TNF alpha thing?
So initially, your immune response is mostly the same. It's why you feel icky after something like a flu shot. Right?
Oh wow, yeah.
But then your immune response over time.
We just got.
Yes, we did just get. Your immune response over time gets more specific.
Okay.
Yeah.
Wow. I'm impressed with that story.
I thought it was super cool, and the science is really elegant. The way that they did the experiments and to prove what they wanted, their hypothesis is a very elegant design too, which is. Oh, I always appreciate.
I appreciate that you bring that in because, like, I skipped right over that article to the one about people over 50 who get less than 5 hours of sleep a night on a regular basis are most likely to get sick very much. And so I'm glad you didn't skip that article. So what
did you find?
So actually, my wife clued me in on something that I'm more interested in, and that's on electric vehicle charging networks. Now, we do know about, like, the Tesla supercharging network and the build back better, I guess, or brought much more of an EV infrastructure. There's
And be really honest.
I think it's not that, it was called the Inflation Reduction Act.
Okay, I was like, I don't know the specifics.
So that act brought in a couple of $1 billion in infrastructure development for wider EV adoption. The bigger issue is we don't have enough EVs to really make a huge dent in our carbon emissions as a country. US, for example, 27% of the carbon emissions come from heavy industrial vehicles.
Oh, so not even passenger cars.
Not passenger cars.
That's
not
interesting.
including passenger cars.
So then what does it tick up to with the passenger cars?
I don't know. But I do
That's
know
almost
that
a
a
third.
solid, I think about 75% of America's emissions are from transportation altogether.
Altogether. It'd be interesting to see the breakdown, you know.
Yeah.
Gibbs and I have talked about this before, and as a sort of strategy person, for me, it would be really fascinating to see the breakdown of the carbon emissions so that you can target your interventions to, you know, what is going to give you the biggest bang for your buck.
Well, yeah.
But I mean, 20%, 27%, it's almost a third of emissions is caused by trucking,
Yeah,
essentially.
so it's trucking. So what'll happen is if trucking is somehow electrified, then you convert those emissions from a polluting coal rolling diesel engine on the road to a different source of fossil fuel or wind or hydro or nuclear for that source of energy.
Yeah, I was going to say.
Or even coal.
Yeah, I was going to say, does it... I'm interested to see the calculations of, like, if you switched everything to electric, then you'd have to look at the sources of the electricity.
Yes, you do. So let's say you just switch it to coal.
Yeah.
Interestingly enough, a turbo diesel engine in a big rig is going to run at around on the highway at around 38% efficiency. So that means I guess 62% of your gasoline or diesel turns into emissions and heat.
Right.
So in other words, you're throwing that away. Just simple as that. And that's just in the engine. We haven't accounted for transmission, aerodynamic loads. We're talking about the plant, the prime mover. If you convert that to coal, say we convert it to coal.
Well, you convert the truck to electric, but the
power is only from coal.
Okay.
It's
like, we're not making a coal-powered truck.
No. But a coal plant.
Yeah.
So let's say you have like the James Gavin plants on the Ohio River Valley. That's a 2 gigawatt coal burning modern plant. I don't even know if it's open now. I remember seeing it 20 years ago. But James Gavin generates a couple of gigawatts at around 65 to 70% efficiency.
So you would have a gain even if you're getting your power
You
from
would
it.
have a gain, yes.
This is an important point because I have seen opponents of electric vehicles make this argument that it doesn't matter what your vehicle does if the power is not clean power. But what you're saying is it does matter because the power plants are more efficient. So even if you switch everyone to electric vehicles and there's still some coal or natural gas power, then It
is. And let's say worst case, your transmission efficiency is 98%. Then 0.98 times that efficiency. And then let's say your round trip efficiency of the electric vehicle motor drive unit is around 92%. So if you take 0.92, let's say I put in a calculator, 0.92 times 0.98 times 0.7, what is that efficiency? And for all those listeners out there, I guess whenever I get excited about a topic, I always want to have a 0.92 times 0.98 transmission efficiency times 0.7.
It's 0.63.
Okay. So you're still a little bit more than double the efficiency. So let's say we switch to only coal burning plants charging our electric vehils.
We are not advocating for switching to only coal
Yes,
boil.
clean, beautiful coal. No.
I feel like we have to put a disclaimer. We are no way advocating for that.
But let's assume, I think about 12% of the electricity generation in the U.S. is nuclear. And then we also have a growing amount of it is wind and solar. But a large amount of it's peaking natural gas plants.
Yeah.
Those don't operate quite as efficiently. I think they're around 60% to 50% efficient. But in any case, natural gas turbines, probably best case is 50% efficiency. You're still going to see a net improvement.
Yeah.
And let's not assume that peaking natural gas, because the word peaking is in there. It's only for peak load periods. Most truckers are going to drive all day, charge all night. And we don't account for the vehicle to grid benefits of a parked truck fleet. Because let's say, for example, you have a 150,000 watt vehicle to grid interface. Presently, Fermata Energy sells a 15 kilowatt fast charger for electric vehicles, which is 2 to 3 times more speed than what you get on a publicly available charging station at the mall, for example. That system is designed not only to give you vehicle to grid back and forth so that the EV can feed the mall with its power, but 2, doesn't void the warranty on Nissan electric cars. So your vehicle warranty is okay even if you use it. So now everyone's aware.
I wonder if it's still okay for the Ford trucks.
For the trucks?
Because that's a big selling point for them.
It
is the fact that this is a grid tie system.
Yeah, that whole thing about, Texans love their big trucks. Well, I think the Ford F-150 Lightning with the 7,500 watt plug-in in the bed.
They've been in Texas. It's not a bad bet.
Not a bad bet. And if you can connect that with a vehicle to grid infrastructure, you get 2 benefits. Texas is a huge wind energy producer in the U.S. It has an independent grid from the rest of the U.S. and could definitely benefit from something like vehicle grid to grid technologies.
But what was the news that you heard that prompted this deep dive?
Well, yes, I did go deep. The news was that Terawatt Energy, a San Francisco startup, is sitting on $1 billion to build an electric vehicle charging network to rival the Tesla supercharger network from San Francisco, Long Beach. That's right, Port of Long Beach, all the way to El Paso.
But a network for what?
Heavy trucks.
Heavy trucks.
Yeah.
I wonder if anyone could plug in, if it's just going to be specifically for the trucks.
It's designed specifically for the trucks. So the trucks are going to have a different connector, mainly because you want a fast charge for the truck. You better be ready to be pumping a few 100,000 watts.
Yeah, because you don't want the truck drivers doesn't want to sit there for probably time they're not getting paid if they're not driving.
And so what will happen is you're going to have to run substations. And those substations are going to have to be able to have at least capability for a couple of megawatts of power for peak load, so that trucks can help each other, and as well as trucks.
Who's building those types of trucks now?
So that's what's interesting. We had a lot of early interest in truck development that got a lot of funding. Recently, actually this week, the former CEO of Nikola was charged with investor fraud and will be doing some jail time for
they give him some jail time. You gotta make it
kind of like with Theranos.
I don't think she's been sentenced yet.
She hasn't been sentenced yet. Well, this guy, Nikola guy, he was caught red-handed.
Well, I would argue she was too, but
yeah, I know, that was tough. Well, in any case, that particular area of truck development continues. So Tesla's truck has been spotted on ramps and off ramps, I guess idling while they do some tests here and there. But Tesla's got one that's rolling out. I also heard last week that the old Youngstown factory in Youngstown, Ohio, where there was it was bought out from GM, and they're building an electric truck there. I can't remember the name of it. But
cool.
That's another EV. Of course, Rivian was.
Rivian, I thought was more of a passenger, like a.
Yes, but Amazon's delivery fleet was going to have 100,000 Rivian trucks by the end of this year, which is not happening. And I think Rivian right now is just struggling to get their standard consumer orders out.
And then supply chain issues are hitting everybody.
They're hitting a lot of people. In fact, Lucid was also hit by some significant supply chain issues and won't be.
I don't feel so bad for Lucid when you charge $180,000 for a car.
Well, it wasn't quite that expensive. It was like $120.
I went on the website. It was $180.
Well, Cadillac now has a $300,000 top of the line EV to test its brand.
We won't be getting that one. Well, that's really interesting. Well, you've wasted another almost 20 minutes with us and our cocktails and our science news for the week. So we're gonna finish our drinks. And cheers. Have a great weekend, everybody.
I think it's called Lordstown Motors. Lordstown Motors.
Okay, to them.
Okay.